Let's look at some trig function values of special angles. The angles that we deal with the most often are going to be 45 degrees, or pi over 4, 30 degrees, which is pi over 6, and 60 degrees, which is pi over 3. So I want to look at easy ways to calculate trig functions of these particular angles. Let's start with a 45-degree angle. Since we know the angles of a triangle have to add up to 180, that tells me that this other angle is also 45 degrees, which means this is an isosceles right triangle. So these two sides have to have the same length. Let's say they're 1. Pythagorean theorem then gives me that this side must be the square root of 2. So if I want to find sine of 45 degrees, sine is opposite over hypotenuse. So the opposite would be 1. The hypotenuse would be square root of 2. Multiplying the top and the bottom by the square root of 2, 1 times the square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. For cosine of 45, this is also equal to adjacent over hypotenuse. Adjacent is still 1. Hypotenuse is square root of 2. So just like sine, the cosine of 45 degrees is square root of 2 over 2. For tangent of 45 degrees, tangent is opposite over adjacent. The opposite is 1 and the adjacent is 1, so tangent is just 1. Cosecant of 45 degrees, this is the hypotenuse, square root of 2, over opposite, which is 1, or just square root of 2. Secant of theta, or secant of 45 degrees, is equal to hypotenuse, which is square root of 2, over adjacent, which is 1, so we have square root of 2. Finally, cotangent of 45 degrees, we have adjacent over opposite, both of which are 1. So I now have my 6 trig functions for 45 degrees. Now let's consider a 30, 60, 90 degree triangle. This actually has sides 1, 2, square root of 3. So let's start with 30 degrees. For 30 degrees, my opposite side is going to be equal to 1. My adjacent side is going to be equal to the square root of 3. And my hypotenuse is going to be equal to 2. So sine of 30 degrees is going to be opposite over hypotenuse, or 1 over 2. Cosine of 30 degrees is adjacent over hypotenuse, so square root of 3 over 2. Tangent of 30 degrees is going to be opposite over adjacent, so 1 over the square root of 3. We multiply both the top and the bottom by the square root of 3 to get the square root of 3 over 3. Cosecant of 30 degrees, this is hypotenuse over opposite, so 2 over 1, or 2. Secant of 30 degrees, secant is hypotenuse, which is 2, over adjacent, which is square root of 3. We can multiply the top and the bottom by the square root of 3 to get 2 square root of 3 over 3. And finally, cotangent of 30 degrees. Cotangent is adjacent over opposite. My adjacent is square root of 3 and my opposite is 1, so this works out to be the square root of 3. So now I have my 6 trig functions for 30 degrees. Looking at my same triangle for 60-degree angle, this time my adjacent side is equal to 1. The opposite side is equal to the square root of 3. And the hypotenuse is equal to 2. So sine of 60 degrees Sine is opposite over hypotenuse, so square root of 3 over 2. Cosine of 60 degrees. Cosine is adjacent over a hypotenuse, so 1 over 2. Tangent of 60 degrees. Tangent is opposite over adjacent, so square root of 3 over 1, which is the square root of 3. Cosecant of 60 degrees. Cosecant is hypotenuse over opposite, so 2 over the square root of 3. Multiplying the top and the bottom gives me that this is 2 square root of 3 over 3. Secant of 60 degrees, this is hypotenuse over adjacent, so we have 2 over 1, which is 2. Finally, cotangent of 60 degrees. Cotangent is adjacent, which is 1, over opposite, which is the square root of 3. Multiplying the top and bottom by square root of 3 gives me square root of 3 over 3.